Welcome to this web lecture on clustering for data preparation. In a previous web lecture, we looked into clustering for placing a facility in a continuous plane, and now we're going to use similar methods to actually, instead of placing facilities, aggregate, for example, different locations. So let's look back into the example of Woodwork BV. They're operating several sawmills throughout the Netherlands, and now they would like to expand into Belgium. So in Belgium, they would like to place their sawmills using the facility location problem. They already tried implementing that, but their current implementation fails due to the computational burden, and they're trying to reduce the input size, which means that they have to bring together similar workshops and just treat them as one. So this is what we refer to as clustering demand or clustering any sort of input. So for example, here we have these different workshops, and we would like to aggregate those workshops together in a way that fits. So for example, we can just use the province centers, but this results into several issues. So first of all, these two workshops here on the top are being treated as one, even though they're extremely far away. On the other hand, these workshops down here, which obviously should be one cluster, are being treated as separate ones because they're located in different provinces. So of course there's better ways of doing that. So one option, for example, would be clustering them like this. That gives us slightly fewer cluster centers and a considerably lower deviation. And so how are we actually clustering demand, and why are we doing that? So if we want to cluster demand, we would like to combine locations in a way that some parameters can be added up. So for example, if we look back one slide here, the demand of these locations should be treated as one. On the other hand, some other parameters will have to average out. So if we look back into this slide, then let's just say we're placing a workshop here, and then the distance between these locations and this sawmill here should be roughly the same. And lastly, stochasticity may balance out or not. So this is also something to consider. Many methods for clustering demand exist, and in the previous web lecture we looked into k-means clustering, and this algorithm also works quite well for clustering demand. However, if we do this, we really have to choose the right number k. In a facility location setup, the k has a very natural interpretation. So this is the number of sawmills. If we're using this to cluster input, then we no longer have this extremely natural interpretation. And if we don't have a natural interpretation, we might have to try out different values. So we have to keep our k small enough that we remain computationally feasible. But we also need to have a k that is large enough to reach a reliable message, so that we don't just average over everything. And of course, we should also represent actual underlying clusters. So I think XKCD did a brilliant job at explaining this. So if we use 3 clusters, so k equals to 3, and then we say, okay, this one cluster explains everything and these 2 other clusters have 0 interpretation, 0 meaning, then maybe my k was wrong. So what I would like you to take away from this web lecture is, first of all, how we're clustering input and why we're clustering input. And secondly, why it is important to choose the right k. Thanks.